Hi, ladies and gentlemen. Notes 1.6 are on transformations of functions, and this is one of 2 days worth of notes on transformations of functions. This is probably the most important topic of the entire unit. So please make sure you are really understanding what's happening and you go through this video very carefully. So let's summarize what we've learned in the transformations of graphs activity, which is what we did when we explored how to do transformations of graphs using graphing calculators. So if you remember, when we had a vertical shift up or down, so if we take our parent function and we either move it up or down, we end up getting y equals f of x plus c, and if c is positive, it goes up. So if c is positive, it goes up, and if c is negative, it'll shift down. Okay? And then remember, if we have a horizontal shift, this is the one that kind of is backwards, right? So what ends up happening is we end up getting y equals f of x minus d right here. And the reason why this is a negative is because it goes backwards, okay? So for example, if I have f of x minus 3, that means it went to the right 3 units. If I have f of x plus 3, that means it went to the left 3 units because we always take the opposite sign right here. Now let's make sure you understand why this is the case. So if I have y equals f of x plus c right here, all this is saying is you just have to add c to the y. You're taking the original y right here and you're adding c to it. So if your original y was 5 and you add 2 to it, you're now at 7, which is 2 higher than 5. Okay? But if I have y equals f of x by minus 3 right here, what's really happening is this x minus 3, it's not in terms of y. So it's really kind of like x minus 3 equals 0. So x equals positive 3, which means it shifted to the right 3. All right. So for questions 1 and 2, the directions say to graph the following functions using their parent functions and your knowledge of vertical and horizontal shifts. So if you take a look right here, g of x is equal to x squared plus 2, we know that our parent function is going to be x squared. And we learned in our video to draw out our parent function of x squared, our quadratic function, we know it's going to be a parabola. So when my input is 0, my output will be 0 because 0 squared is 0, right? And I'm just graphing out the parent function right here. When my input is 1, my output is 1 because 1 squared is 1. When my input is 2, my output is 4 because 2 squared is 4. When my input is 3, my output is 9, but there isn't enough room on my graph, so I won't worry about it here. When my input is negative 1, the output is positive 1. When my input is negative 2, the output is positive 4. So this right here is going to be the graph of my parent function, of my parent quadratic function right here. So I'm going to label this p of x, okay, equals x squared. Now, what is this saying right here? Well, this plus 2 is on the outside, which means g of x is equal to the output plus an extra 2, which means that it gets shifted up by 2. So what I'm going to do is I'm going to take each point right here and I'm just going to move up 2. So here, this goes up 2, start at 0, go up 2, start at 1, go up 2, and we're at 3. Here, start at 4, go up 2, and we're at 6. So this right here is the function that's given to us. G of x is equal to x squared plus 2. Okay? Now in question number 2, this time the plus 2 is on the inside of my brackets, which means that you are adjusting your input. And remember, it's going to be the opposite direction. So this is saying that you are going to go to the left by 2 as opposed to going up by 2 right here because it's on the outside of what the parent function originally is. So our parent function is still p of x equals x squared. So I'm going to graph that out again, 0, 0, 1, 1. I have 2, 4. I have negative 1, 1, and I have negative 2, 4. And so here's my original parent function. And since we know that it's going to shift to the left 2, I'm going to take each point and just move to the left 2. So here's 1 point, Here's another point. 0 becomes -2 right here. This 1 becomes -1 right here. And then this 2 switches over to 0 right here. And this is what my graph is going to look like. So here I can say that this is h of x equals the quantity x plus 2 squared. For 3 through 4, it asks us to determine the parent function and the transformations that result in f of x. So if you notice right here, we've got a square root right here. So that means that my parent function is going to be the square root of x. And if you remember, the square root of x, I'm just going to do a rough sketch of it so you can kind of see what we're talking about. If you remember, the square root of x kind of looks like that, okay? Now, if you notice right here, you have a -2 connected with the x. It's under the square root sign, so it's connected with the x. So what this means is that you're going to the right 3. And then this right here is outside of the square root, so it means that it's the y that's changing right here. So this is saying you're going down 3. So my two transformations are going to the right 3, and then we're going to go, to the right 2. I wrote this down incorrectly. And then we're going to go down 3. So if I were to look at my graph, I would just go to the right 2 and down 3, and then my graph would end up looking like that instead. Okay? All right, so now in number 4, if you notice right here, our parent function is going to be the absolute value function because it says g of x equals the absolute value of x plus 1 and then plus 2 on the outside of that. So if you remember, the absolute value function looks like a v, right? So right here, what this plus 1 right here is saying, since it's with the x, it means that we're going to the left 1. And then this plus 2 is on the outside, so that means we are going up 2. So I'm going to go to left 1 and up 2, and then this is what my graph would end up looking like right here. Okay? Okay, in number 5 it says, given the parent function f of x equals 1 over x, and if you remember, this is the reciprocal function, find the equation of the function that is the transformation of f of x when shifted up 7 and to the right 8. Since it's up 7, that will be the plus c over here. So it's going to be on the outside of my parent function piece. It's going to be an extra piece added on to the output, okay? And then since it's right 8 right here, since it's a horizontal shift, it will be inside of the reciprocal function. So how do I do this? We're going to call this right here anything other than f of x, so we'll call it g of x, is equal to, now if I'm going to go up 7, I know I'm going to have to add 7 at the end. And since it's the reciprocal function, it's 1 over x, right? But since I'm going to the right 8, the 8 belongs with the x, and it's always the opposite when it's with the x. So it's 1 over x minus 8, and then plus 7 at the end. Okay? All right. Number 6, given the function f of x equals 3 times the absolute value of x minus 5 plus 4, find the equation of the function that is the transformation of f of x when shifted left 6 and down 2. Now, it's left 6 and down 2 from this function, not from the parent function. So what that means is I'm going to take f of x, I'm going to keep the 3, I'm going to keep the x minus 5, but since it's going to the left 6, I'm going to add 6 onto this absolute value piece right here, because the left 6, remember, you have to do the opposite, so I would add 6 right here. Okay, and then I'm going to keep this plus 4 right here, and then if I go down 2, I have to subtract 2 from that value. Okay, and sorry about this, it's not f of x anymore, it has to be something new, so we'll call this h of x. So that means that my final equation, when I put my like terms together, ends up being 3 times the absolute value of x plus 1 plus, and then when I put those together, I get 2. Now, that should make sense to you, because if you look at it like this, what this is saying is you're going to go to the right 5, and this is going to say, sorry, from the parent function, the absolute value of x. So I'm going to go to the right 5 from my parent function, and then I'm going to go to the left 6. So if I go to the right 5 and then I go to the left 6, essentially what I'm doing is I'm just going to the left 1. Okay, and this is saying that I'm going to go up 4 from my parent function and then down 2, so altogether I'm just going up 2. Okay, all right, number 7. The function shown below is f of x. So right here we've got f of x right here. Draw in g of x if g of x is equal to f of x plus 2 minus 1. So let's digest what this is saying. This plus 2 piece right here is saying you're going to go to the left 2. Okay? This minus 1 piece right here is just saying you're going to go down 1. So I'm going to take every single one of my coordinates and I'm going to do exactly what our directions are saying right here. Left 2, down 1. So here's 1 point. Go left 2 and then down 1. I end up right here. Okay, I end up at negative 5, 2. Here, if I were to go left 2 and down 1 right here, I end up at negative 4, 1. Here, I would go left 2 and down 1 right here, and that's where I end up at as well. Please continue with the remaining 1, 2, 3, 4 coordinates, and then compare your answers with mine. Here are all of our remaining values right here. And if you connect your dots, you end up getting a graph, that looks just like this right here. So if you notice, my graph looks the same, it's just in a different spot on my coordinate plane. Okay, so that's essentially how you do horizontal and vertical shifts. So now we want to talk about reflections, but here's a reminder of something you guys used to do when you were in elementary school. So when you reflect in the x-axis, so here, if I had a coordinate here, for example, this is the coordinate xy. When I reflect in the x-axis, here's where my new coordinate is. So my x value stays the same, but my y becomes the negative value. So that's what this is saying right here. Before the reflection, your coordinate is xy. After the reflection, your coordinate will be x negative y. Okay? And then if I were to reflect the original coordinate xy right here over the y-axis, I would end up right here, and my x value would become negative, but my y value will stay the same. So essentially, when you reflect in the x-axis, y changes to its opposite sign, and when you reflect in the y-axis, you need to negate the x value. So question number 8 says, graph the following function below. Then graph 2 reflections, one over the x-axis and one over the y-axis, and then determine the equation of each function. So if you notice right here, this is essentially our parent function of x squared that's shifted to the right 3. Okay, so if I were to graph out my parent function, just like we did earlier, here are the coordinates of my parent function right here. And then I'm going to shift all of my coordinates to the right 3. So this coordinate of negative 2, 4 ends up being at 1, 4. This coordinate of negative 1, 1 ends up being 1, 2, 3 at 2, 1. 0, 0 ends up at 3, 0. This value right here, this 1, 1, I move it over 1, 2, 3, I'm at 4, 1. And then when I take 2, 4 and I move it over 3 to the right, 1, 2, 3, I end up at 5, 4. So to make my life easier, I'm going to erase my parent function right here because I don't really need it so much for this question, and I'm just going to graph out the function that's given to me. So this right here is f of x is equal to the quantity x minus 3 squared. So now let's reflect this over the x-axis. So this coordinate right here of 1, 4, I'm going to go down 4 to get to the x-axis, and then I'm going to go down 1, 2, 3, 4 more. So I end up at 1, negative 4. So if you notice, if the original coordinate was 1, 4, the new coordinate was 1, negative 4. It's kind of like what we talked about before. When you reflect in the x-axis, your y value becomes the negative sign. So right here, this 2, 1 becomes 2, negative 1. 3, 0 is right on the axis, so it stays in the same spot. 4, 1 goes down to 4, negative 1, and then 5, 4 goes down to 5, negative 4. So this is my reflection in my x-axis, okay? So now we want to talk about what the equation is after reflection over the x-axis. So here's where things get a little bit tricky. So remember how we've said that y is equal to f of x always. So y and f of x are going to be interchangeable with each other. So if my original f of x is equal to x minus 3 quantity squared, we know that the y value is going to become the opposite sign. So essentially what I'm going to do is I'm going to take my y value, or in other words, what f of x is, and I'm going to negate it. So I'm going to say it's negative f of x. But I'm not allowed to have a negative f of x. I can only have a positive f of x. So to get rid of it, I'm going to divide both sides by -1, which means that my new function is going to be f of x equals the negative x minus 3 squared. We can't call this f of x because that's the original function that we had here, so we're going to call this g of x is equal to negative the quantity x minus 3 squared. And that's the equation that I should end up getting. Let's verify this with Desmos. So if you look right here, our original function says f of x equals x minus 3 squared. So that's exactly what we ended up getting when we graphed it out. And if you remember, your y value is going to become negative. So I'm going to take my f of x, which is my y value, and I'm going to make it negative. And this truly is a reflection in the x-axis, okay? So let's just verify that our equation lines up right here. So x minus 3 quantity squared with a negative in front, it is a reflection in the x-axis. All right, so now let's go ahead and do our reflection over the y-axis. So right here at 1, 4, I'm going to take one step to the y-axis and then one more step to get to my reflection, which is at 1, -4. Here I'm going to take 2 steps to get to the y-axis and then 2 more steps to get to my reflection. So it's right here. And I'm going to continue doing that with the remaining 3 points that I have. So here this 3, 0 becomes -3, 0. And then I have another point at -4, 1. And then my last point is at -5, 4. So if you remember, when we reflect over the y-axis, the x value becomes negative. So if our original function is f of x equals the quantity x minus 3 squared, then my new function, so we'll call this one h of x, is equal to, now the x is changing. So inside my brackets, I'm going to say negative x minus 3 squared. Okay, so let's go ahead and verify this with Desmos. So I'm going to say h of x is equal to negative x minus 3 to the power of 2, and sure enough, this right here is a reflection in my y-axis. So my summary, I can say that before the reflection, it's f of x. After you reflect in the x-axis, and let's say y equals f of x right here. So after you reflect in the x-axis, remember the y becomes negative. So I'm going to say y equals negative f of x because the y becomes negative, okay? And then if I reflect it in the y-axis, remember the x becomes negative. So y equals f of x becomes y equals f of negative x, okay? All right, so this is where we're going to end our part 1 video, and then the next part of our notes we're going to finish another day for homework, but this is all you need to have filled out just till question 8. Questions 9 and 10, don't worry about filling those out because you'll watch a whole video on them. They're pretty complicated questions, so I just want to make sure you're 100% okay with that, and that'll just be a focus all by itself another day. Okay, see you next class.